Welcome to this series of introductory lessons related to the time value of money. My name is Brent Pritchard. I teach college finance courses, and I'm here to help you grasp this all-important concept. This introductory series is designed to help you learn how to apply the mathematics of finance in less than a month, provided you commit to one or more lessons a day. It's that easy. Acquiring the hard skill that is the mathematics of finance does not need to be hard. I hope you enjoy this fun new take on this age-old concept. And after you've done that, please consider telling your friends about this channel, TVM Rules, and the book, Would Your Boomerang Return, also known as the Boomerang Book, that made it possible. I always start class with a quote. Here we go. The quote of the lesson comes from Kate Arnett. I really enjoyed working with Kate. She taught me a lot over the 22 years that we worked together, either directly or indirectly. Thank you, Kate, for this great advice. I haven't forgotten it. In this lesson, we'll be making some assumptions that relate to math where thankfully it's okay to assume. This lesson is closely related to the one on the topic of the 3-1-2 warm-up routine. In that lesson, we said that the first thing that we need to do is count money and then tell time on the timeline to ultimately read and write I, the true investment yield. In this lesson, we take a deeper dive into how to determine the true investment yield. On this slide, you see the building block true investment yield equation. This is what we're going to be working with in this lesson. Again, S stands for the simple investment yield. C denotes the number of compounding periods within the time span of the simple investment yield. And N represents the number of actual or as-if compounding periods within the time span in between periods or payments on the timeline. We'll get to what I mean by as-if compounding periods toward the end of this lesson. Before you can apply the mathematics of finance to analyze or evaluate real-world time value of money situations, first you need to circle the I you'll be using, and not just any I will work. The time span of the true investment yield needs to match the time span in between periods or payments on the timeline. So this slide describes the three conditions that you're going to encounter when you're applying the mathematics of finance. Before we can do the DIY work that is calculating the true investment yield, it helps put some words to the numbers. In the building block true investment yield equation, I'm referring to what I call the caterpillar rate, which is S, the chrysalis rate, which is S divided by C, and the butterfly rate that is I. That is the only rate that will fly. I'll show you what I mean as we work through the real world situation. So here's the first of a few real world situations. Notice that this equation is not asking you to solve for future value, instead only the true investment yield. For this question, it's assumed that we want to tell time on the timeline with a quarterly time span in between period markers. So let's get about drawing the timeline. I'll make sure the tablet is on here and we've got the right color. Okay, very good. So here we go. We have a 1-year investment horizon, and we're told that the time span in between periods on this timeline, because there aren't payments on this timeline, there's a payment, a lump sum payment, a single payment. So the time span in between periods on this timeline, we're dealing with quarterly periods or a quarterly time span. We like to fill in the blank, and that's a quarter. There are 3 months between the period markers on this timeline. Because we're telling time quarterly, only a true quarterly investment yield is going to work. So like we do, let's write out the building block true investment yield equation in the upper right hand corner of this slide. There it is. And we're going to be putting words to these variables. So we start with a 10% investment yield. Let's put a few more words to this. It's a simple annual investment yield. This is what I call the caterpillar rate. So that's our starting point. We're told that compounding happens quarterly. So over that annual period, over the duration of that simple investment yield, compounding is going to happen 4 times. Okay, this is where I see a lot of people struggle a little bit. And I think the reason why is they're not putting more words to it. That's why I came up with the caterpillar rate, the chrysalis rate, and the butterfly rate, the last one being the only one that'll fly, that is I. A lot of people will look at this and they'll see 10%, that's the percentage format, in decimal form it's 0.10, divided by 4. That's what a lot of people see. But what I want you to see is that when you work this out, and this is what's in parentheses, when you work this out, it becomes 0.025. That's 2.5%. Notice how that looks a little bit like a chrysalis. I mean, you can't make this stuff up. It's pretty cool. So there's our chrysalis rate. Now let's complete this building block true investment yield equation. Our chrysalis rate. We can fill in the blank. What is this chrysalis rate? This chrysalis rate is a simple what yield? Well, the chrysalis rate is a simple quarterly investment yield. We're looking for a true quarterly investment yield. So how do we take what's within the square brackets and ultimately turn it into a rate that will fly? That is I, a true quarterly investment yield. Well, to do that, lowercase n takes the value of 1. And when we work this out, we get, which is 2.5%, which is a true, let's fill in the blank, quarterly investment yield. Now, if you're looking at this, you're thinking maybe, hey, that's the same investment yield. The butterfly rate is the same as the chrysalis rate. I get it, but for the building block true investment yield equation, so in other words, in every other building block time value of money equation, you're only going to find I. S and C, they're nowhere to be found. That's why we keep our eye on I. The butterfly rate is the only rate that will fly, and it pays to work it out from left to right and determine I. It's just good form. And so we did that there. Well done. Let's move on to the next real world example. I'm going to draw another timeline. This time, our timeline only has one time period. We're going to fill in the blank because that's the way we do it. That is an annual time span in between period markers. So only a true annual investment yield is going to work. Let's go back to the building block true investment yield equation and put some more words to this. We start with a what? Well, it's a caterpillar rate, but it's also a simple annual investment yield. Why do we divide by 4? Because compounding will happen quarterly, and there are 4 quarters in a year over the duration of that simple investment yield, the simple annual investment yield of 10%. This goes in parentheses. Now, this is the chrysalis rate. But what is the chrysalis rate? Let's call it by name. it's a 2.5% rate. It's a simple quarterly investment yield. So when we divide the decimal form of 10% by 4, we get 0.025, which is 2.5%. Now for this question, we're looking for the true annual investment yield. So it helps to ask the right question when we're at this point. The chrysalis rate is a simple quarterly investment yield. How many quarters are in a year? The answer is 4. So that's the value for n. And when we work this out, we get that is 10.3813%. That is a, and that is the letter that goes here, that is a true annual investment yield. Again, that's the butterfly rate. It's the only rate that will fly. It's I. It's what we're looking for. Let's move on to the next real-world example. For this third real-world example, it's assumed that we want to tell time on the timeline with a monthly time span in between period markers. So let's draw the timeline. And then we'll jump up to the building block true investment yield equation. So this is abridged. Let's fill in the blank. How are we telling time on this timeline? We're telling time with a monthly time span in between time period markers. So only a true monthly investment yield is going to work. So let's go back to the building block true investment yield equation. We start with 10%. Let's use more words. It's a simple annual investment yield. I'm going to call it the caterpillar rate. I hope you'll join me because I think it's easy to remember. Why do we divide by 4? Because compounding happens quarterly over that year. So we're left with the product of that is 0.025 or 2.5%. That's our chrysalis rate. We're going to add 1 to that because that's what the building block true investment yield equation tells us to do. And now we need to figure out what's our value for lowercase n. Again, it helps to ask the right question. So the question that we need to ask at this point is what fraction of a quarter, because we're dealing with a simple quarterly investment yield for the chrysalis rate, what fraction of a quarter is a month? Because we're ultimately looking for the true monthly investment yield. I think I'm saying that right. What fraction of a quarter is a month? Again, it helps to put more words to these numbers. So n takes the form of a fraction, a third, 1/3. And when we work this out, we get 0.00865, which is 0.8265%, which is, let's fill in the blank, a true monthly investment yield. So it's the butterfly rate. That is the only rate that will fly. So again, we worked it from the top. We started with a caterpillar rate. We determined the chrysalis rate. And then we figured out how to get to I, that is the butterfly rate. Okay, before we call it a wrap, we're going to change it up a little bit. This last, I'll call this the bonus example, because this last real world example was taken from the last lesson, but we've modified it a little bit for this lesson. This time, There's no information related to the compounding period. We're going to assume quarterly compounding for this true investment yield. Also, I don't think I pointed this out the last time, but notice how there's no reference in this question to future value. That's implied in the sentence with the words, what amount do you expect in the future? This is typical, and it requires that you're able to interpret what the situation is asking for. Here's the key takeaway from this question. You can assume, there we go again, we're talking about assuming, any compounding period to your heart's content, so long as you realize that that's simply an assumption and may not be realized or available in the market. Remember the reason why we don't store money under mattresses? Because there are markets for capital or money. That's the short answer. So let's work out the math. We're going to be drawing our trusty TVM wallet. I'm going to leave a little more room on the right because this example requires a little more work, but it's not rocket science. I'm guessing that's hard, right? We have 8 periods on this timeline. This is an abridged timeline. And how are we telling time? We're telling time here with a quarterly time span in between period markers. So we're going to put a Q down here in the subscript to remind ourselves how we're telling time. There are 8 periods for this investment period. Only a true quarterly investment yield is going to fly, is going to work. So let's go up here and write out the building block true investment yield equation. This is the place we're going to start. Okay, we were provided with the true semi-annual investment yield. This question requires that we work, for the most part, backward in the building block true investment yield equation. In other words, from right to left mostly. When we get within the square brackets, I guess we're kind of working from left to right, but it really comes down to performing the opposite mathematical operation. You'll see what I mean here in a little bit if you don't already. So we were provided with the true semi-annual investment yield, but that's not going to fly here because we're telling time with a quarterly time span in between period markers on our timeline. Okay, the true semi-annual investment yield that was provided was 1.5 point. Let me try that again. This is what I was trying to do. 1.5094%. So, up here we've got the decimal form, then we move on to the percentage format. So this was provided, this true semi-annual investment yield. This is I. Now here's where I see some other people mess up. This is not S. This is not C. This is I. Now, it's not the I we're looking for. This is why we're going to perform this backward operation, but it is I. So let's call it what it is. Okay. I'm going to get rid of this stuff because it's getting a little, I don't want it to get too messy. Now, this true semi-annual investment yield was provided. It was given, it was the stated yield or rate. We're going to work backward as if, there are those words, as if we calculated this true semi-annual investment yield in the first place. So what was the last mathematical operation on the other side of the equal sign? We subtracted 1, didn't we? Okay, so now what we're going to do is we're going to add 1. So this is where we start. 5094, we're going to add 1. And when we add 1, this is what we get. 5094. Again, we started with a true semi-annual investment yield. Now we have to ask ourselves the right question again. We're trying to put more words to these numbers. And the question that we need to ultimately arrive at is, what fraction of a semi-annual period is a quarter? And that's a half. That's 1/2. That's the fraction. And so here we're going to use that fraction. And that equals 1.007519. So I'm going to get rid of this first step because this is where we're at now. Okay, now we're within square brackets. This is where it looks like we're working from left to right. I mean, we kind of are working from left to right, but again, we're really just performing the opposite of that last mathematical operation to get back to the top, because we're ultimately working to S here. We're solving for S. We're trying to solve for this simple quarterly investment yield. And as you'll soon see, the plug number for C is 1. So within square brackets, what happened after if we would have determined the chrysalis rate, what would have we done next? We would have added 1, right? So we subtract 1. And that should be 1/2. I don't know if that got erased or what. So now we're going to subtract 1. And we're left with, I'm trying to move this over a little bit to the left so I can have a little more room here. This is what we're left with. Remember I told you that the plug number for C is 1? So if we had divided by 1, what's the opposite mathematical operation of that? It's multiplying by 1. And I know it's going to get us to the same number, but I think it's just good form because we're trying to go all the way up to S and solve for S. And so when we do that, we get this number right here. This is S. So we've solved for what would be the simple, let's fill in the blank, quarterly investment yield. This is a caterpillar rate. So I want to show you how we came up with this fraction, 1/2 for N, for the value of N in this building block true investment yield equation. And I'm going to fill in the numerator with the decimal form that we just found for 0.7519%. Remember I told you that the plug number here is 1 because we're just assuming, that's the plug number for C, we're assuming that compounding will happen once over the duration, over the time span of the, in this case, simple quarterly investment yield. So that's the plug number for C, 1. And if compounding happened quarterly, and if you started with a caterpillar rate that was a simple quarterly investment yield, then to get to a true semi-annual investment yield, N would need to take the value of 2. So let's read this building block true investment yield equation. We start with a caterpillar rate of 0.7519%. Again, we need to state that in the decimal form in the numerator. That's the caterpillar rate. When we divide by 1, while it's the same thing, we're going to call it by name. It's the chrysalis rate. And that is, this chrysalis rate a simple quarterly investment yield. Now we have to ask ourselves the right question. How many quarters are in a semi-annual period? And the answer is 2. That's why this equation would have taken the value of 2 in this equation to ultimately solve for the true semi-annual investment yield. So I'm going to circle 1.5 here, 1 over 2, that fraction. See why when we were working backward in that equation and we were doing the opposite mathematical operation, do you see why we raised to the power of 1 over 2? Because that's the opposite of 2 as far as this operation is concerned. So we solved for, now we need to solve for the true quarterly investment yield. And to solve for the true quarterly investment yield, because that's the only I that is going to fly, let's work it from the top. We've got a caterpillar rate, don't we? That's in the numerator, 0.7519%. Now in the numerator, it's expressed in decimal form because it needs to be. We divide by 1. What do we get? We get a chrysalis rate. It's still a simple quarterly investment yield. How do we take a simple quarterly investment yield and turn it into a true quarterly investment yield? N takes the power of, N takes the value of 1 here. So we raise everything in square brackets to the power of 1, and we get 0.07519, which is 0.7519%, which is a true quarterly investment yield. Again, it's good form to work it from left to right. It's good form not to stop with the chrysalis rate because a caterpillar doesn't fly, a chrysalis doesn't fly, only a butterfly flies. And so we want to work it all the way out to I. That's what we want to keep our eye on, I. And so we have our I that we can input into the second window of the TVM wallet. It's 0.7519%. Now, once again, my trusty HP12C requires that I input I in percentage format. Your financial calculator may be a little different. We're solving for future value, so I'm going to circle that. We have $9,418.35 in the bank. $9,418.35 in the bank. And we want to determine the future value. There's 0 is the value for PMT payment. Why? Because there's no annuity here. And when we solve for future value, you may remember this number if you saw the last lesson. It's $10,000. So that's how it's done. Now, the last thing that I want to point out before we call it a wrap, when you're manipulating sounds bad, right? But it's good to know how to manipulate investment yields. When you're manipulating investment yields or rates using the building block true investment yield equation, it might help to put some words to numbers like we talked about to call it these rates what they are, as far as I'm concerned, the caterpillar rate, the chrysalis rate, the butterfly rate. But you might also want to think about how to ask the right question to get you from the chrysalis rate to ultimately the butterfly rate. And that question might start with the words how many, like we saw here, or what fraction. So that's a wrap. If you like what you learned in this lesson, please consider telling your friends about this channel, TVM Rules, and the book that made it possible. In the book, Would Your Boomerang Return, I talk about the need to match the hatch. This comes from fly fishing. This means that the person fishing needs to present an artificial fly that matches the hatch of insects that fish are currently feasting on. Just like it takes a little bit of pre-work to see what's on a fish's menu, it takes some time to correspond the time span of the true investment yield with the time span in between periods or payments on the timeline. There's an ancient proverb, I'm sure you've heard it. Give a person a fish and you feed them for a day. Teach them how to fish and you feed them for a lifetime. As of this recording, I've been teaching for over a decade, and I can tell you that manipulating I is right up there with the biggest challenges learners face when trying to wrap their heads around the time value of money. If you haven't purchased your copy yet, all the important information on this all-important topic is wrapped within the cover of Would Your Boomerang Return? Until next time, enjoy the gift that is the present.